On page 21 in your notes packet, we are looking at 8.9, talking about scale and area and perimeter. So we're going to start off with these two triangles that are right here. And scale factor is basically talking about either enlarging or reducing the size of an object. And we saw this when we actually talked about similar figures. So when I look at figure A and compare it to figure B, I want to go ahead and actually focus on just one side. So I'm going to focus on this 16 and the 4. Those are called corresponding sides. And if you remember from similar figures as well as angles, corresponding means that we're in the same spot. So the scale factor from A to figure B, so we want to actually compare B over A is going to be our process here. So for that side on B, we have 4 inches, and on that side on A, we have 16 inches. Because our units are the same on top and bottom, they'll cancel out, and we get 4/16, which is really just 1/4, or 0.25. What that tells me is any of my measurements over here in A, I can multiply by that scale factor and I will result in the same, in that similar side on figure B then. So that does work. 12 times a fourth or 12 times 0.25 will give me 3 inches, and 20 times a fourth will actually give me 5 as well. So that scale factor is 1/4 there. In question number 2, we're going to determine the perimeters of figures A and B. So for my perimeter for part A is going to be 20 plus 12 plus 16. So that perimeter is going to give me a total of 48 inches. Perimeter on triangle number B is going to be 5 plus 3 plus 4, which is going to give me a perimeter of 12 inches. So if we come down here, A is 48 inches and B is going to be 12 inches then. We are going to be looking kind of at 2 different pages here, so I'm going to flip to dual page so we can still see the old picture, and you have this all on one page in your notes, which is kind of nice. So what is the ratio of perimeters from figure A to figure B? So the ratio here from figure A to figure B would be using that 48 over that 12, which is going to be a ratio of 4:1. And we'll see that that actually ties back to our scale factor here. So that is going to be exactly the same thing. So the scale factor is going to match our perimeters here. Find the areas of figure A and B. So if I look at A, and I'm talking about area, it's a triangle. So it's 1/2 times base times height. So I'm going to do 1/2 times 12 times 16. So that's going to give me a total of 96 for this area, inches squared. And for figure B, area is going to be equal to 1/2 times the base of 3 times the height of 4, which is going to be 6 square inches then. So A is 96 and B is going to be 6. So now we want to go ahead and figure out the ratio of A to B. So 96 to 6. And remember, with ratios, we're just trying to reduce these. We're going to treat them like a fraction. So we get 16 over 1. We just get 16, but we need to know that we put that over 1. So we can also write this as 16 to 1. Going back here to scale factor, one of the things that we could do, this is what we would multiply by, but we could also say that it's a factor of 4:1 if we're looking at A to B. So we could have written it out slightly differently here, which is actually going to help us in questions 3 and 5, and then moving into 6 and 7 here. So number 6 says, express the relationship between scale factor and the ratio of the perimeters. So our scale factor, if we use that idea of that 4:1 comparing A to B, notice up in number 3 here, the ratio of our perimeters is also 4:1. So the ratio of the perimeters is going to be the same as the ratio that we have in our scale factor here. So in part 7, what's the relationship between scale factor and the ratio of the areas? So our scale factor was 4:1, and the ratio of our areas is 16:1. So what I want you to realize is really this relationship between 4 and 16. If you take 4 and you square it, you end up getting 16. So because area is a 2-dimensional process, and we have length and width, or in this case, base and height, we have those 2 different dimensions, the relationship between our scale factor and the ratio of our areas is going to be whatever our scale factor is squared. And that worked with the 1 as well. but 1 is kind of the boring case because 1 squared is just 1. So if our scale factor was something, for example, like 2 to 3, we would actually be able to say that the ratio of the areas would actually be 4 to 9 then, because we would have to square both of these parts in our ratios. So that's an important piece to understand. The ratio of the perimeters is going to be equal. It's going to be exactly the same thing because they're linear, one-dimensional, but the relationship between the scale factor of the areas is going to be a squared relationship. So you would take both parts and actually square them. We're going to talk real quickly here just a little bit more about a scale drawing. You can read the paragraph that's there in your notes on page 22. We use scale drawings when the object's too big or too small to actually show in a picture. So when I look at example number 1, Josh made a scale drawing of this flag. He wants to produce a second one, but he wants it to be bigger. So he uses a scale factor of 2. So what I'm going to do is I'm going to figure out the dimensions of the length and the width. So the length right here is 4, and my width right here is 3. So when I use the scale factor of 2, I'm going to take all of those and I'm going to times them by 2. So that tells me that my height is now going to be 6. 1, 2, 3, 4, 5, 6. Sorry, it's a little bit hard on this pen. And then we're going to go ahead and do 8 across here. So there's 2, 4, 6, and 8. What this means for every one block that you saw in the original picture, because the scale factor is 2, you're now going to actually have 2 blocks on all of them. So his new flag is going to be 8 by 3, and he would be able to color that in so they match each other. So your scale factor is either going to enlarge your picture, or it's going to reduce the size and actually make it smaller. In example number 2, a rectangular blueprint is 3 4/5 inches wide, 8 2/5 inches long. Patty is going to make a scale drawing using a scale factor of 5/2. What are the perimeter and the area of the scale drawing? So her scale factor is 5/2. So we're going to go ahead and look at the width, which Patty said was 3 4/5 to start. And we're going to multiply that by that scale factor of 5/2. So 3 4/5 times 5/2 will give me 9.5. And for the length, she said it was 8 2/5 inches long. We're going to use that scale factor of 5/2. And we get 21 then for our length. So the new width is 9.5 inches, and the new length is 21 inches then. So the second part, we're going to calculate our new area and our new perimeter. Since it's a rectangle, it's just length times width. And the perimeter is 2 times the length plus 2 times the width. So for our area, our length is 21 and our width is 9.5. So if we do 21 times 9.5, we get 199.5 inches squared. For our perimeter, if we plug in 2 times our length of 21 plus 2 times our width of 9.5, we get 42 here, plus a 19 here, and 42 plus 19 is going to give us a 61-inch perimeter then. So those are your examples of working with scale and perimeter and area. So keep in mind when you have perimeters of 2 different scaled objects, the ratio of the perimeter will match the scale. And your ratio of your areas is actually going to be that scale squared then.